enough from that. They can suck whatever fluids they want out of it. Lots of blood they can take. They can take whatever urine is there. They can take the vitreous humor. That's the fluid in the eyeballs. So for cadavers, it's usually enough for them to work on, even though it's not easy. But for living things, really, the most you can get is blood and urine. You're not going to get the eyeball fluid, and you're not going to get that much blood. For alcohol problems, you need is 5 milliliters. But for a comprehensive toxicological examination, you need to have 10 milliliters of blood ready to use for their whole analytical scheme. So you need more, but 10 milliliters of blood is nothing to sniff at. That's well, in my opinion, a significant amount. It can be done, but the point, well, at least taken at once. Anyway, so you take 10 milliliters of blood at once. That's very significant. But anyway, the forensic toxicologist to do a comprehensive toxicological examination really needs 10 milliliters of blood in order to do it thoroughly. So. And also other samples. And if you can get the urine, they should also get the urine. That also helps. Most of the time, however, it's pretty easy. It's drugs. Sometimes it can be poisons, but most of the time it's just drugs. So again, if the forensic toxicologist knows the situation, they'll know. Oh yeah, that's not a poison. That's just drugs. So they'll be able to eliminate a lot of possibilities and get to work on the real analysis of the drugs and do a better job of it. And of the drugs, it's 90% of the time it's alcohol, marijuana, or cocaine. These are the most popular drugs. So the majority of cases, it's really not that hard, depending on what the forensic toxicologist what information they have to work with. If they just find a dead body, then it's a lot harder. You have no idea what killed it. Alcohol, drugs, poisons, or none of the above. It's important to know, and the more information that the forensic toxicologist has, the better and the more reliable their analysis. So the first thing they do is they try to, when they don't know what it is, they try to classify it as 3 different things: acid, base, or neutral. And again, once they divide into 3 parts, they divide it, and each one is individually more easy to analyze. Just an idea of what are acids and what are bases. An acid is something that, when in water, produces H+. This cation, the H+. Now, I realize that some people know a lot of chemistry and they say, well, that's not the Lewis definition. Okay, we're not going to do the complicated one. The simple Arrhenius definition is fine with us. When in water, it produces H+. This is an acid. Okay, that is an acid. If it produces the H+ in water. HCl4 produces H+ in CO4. Yes, it's an acid. Okay, other compounds, this is KOH, that's potassium hydroxide, produces this potassium, which doesn't do much, although you might remember it from finding the time of the dead body. It's found in the vitreous humor. Okay, never mind that. This produces OH-. Okay, this OH- is an anion, and this makes it a base. If it has OH- in there, it is a base. Okay, here's another example. We have NaOH, that's sodium hydroxide. You might be familiar with it as lye. But anyway, you put sodium hydroxide in water, it'll produce this, harmless stuff, and your OH-. This makes it a base. Okay, so we have the H+ making it acid, OH- making it a base. When the two will neutralize each other. You have something with an acid, you can eliminate it with a base. We have something that's a base, you can eliminate it with an acid. The reason why is that having the H+ makes it an acid. You have the H+ here. Having the OH- makes it a base. When you have the H+ and the OH- and the positive and negative get together, H+ and OH-, well, HOH, right? But this is 2 H's and one oxygen. H2O. That's what it is. That's water. That's how it neutralizes, how the acid neutralizes the base, and the base neutralizes the acid. You have a lot of the H+, put the OH- in there, they combine and form water, which is completely neutral. Some compounds do not have either the H or the OH. They're neither acids nor bases. These are neutral compounds. Well, many compounds are neutral. So that is one way to differentiate different kinds of drugs. Some kinds of drugs are acids, like barbiturates. Barbituric acid is an example. Some of them are bases like cocaine and crack. So if you can divide the blood, whatever's in the body, into three different parts, acid, base, or neutral, you can say, okay, I know of the acids, I have to test only for a few of them. Of the bases, I know I have to test only for a few of them. So it's a little bit easier to find exactly what was in the body. Okay, here is how it's done. You have to understand something else. It's called extraction. It's very commonly done in organic labs. I've done it quite a bit myself, and tell you the truth, it can be a beautiful thing. I mean, I used to have this ugly brownish mixture. I did an extraction, and I divided it up into two beautiful, differently colored. One was nice, flashy yellow. One was a deep purple, beautiful stuff. And I divided, and they were perfectly well separated. Okay, not perfectly, but it was actually elegant if you would actually watch the thing in action. In any event, we can do the same thing, or the forensic toxicologist does that. It's one of the things that they do. They divide, using extraction, they can divide things into acids, bases, or neutral compounds. The idea is oil and water don't mix. Oil floats on top of the water. Now you have organic compounds. They don't always float on top of the water, but oil will sink below the water, depending on which organic compound. Let's work with one that's lighter than water, and many of them are. So, ionic substances, meaning if they have the ions, we've seen ions are like the positive or negative. If they have ions in there, they will be in the water. They'll end up in the water. If they do not have any ions, they'll end up in the oil layer or the organic layer. So what we want to do is we want to, let's say we have it originally in water, we want to remove the others, keep the ion, make one of them, let's say the base, turn that into an ion, that'll stay in the water, the others will go into the oil. Or we want to remove the acid, turn the acid into an ion. The acid will stay in the water, base will stay in the oil, and the neutral also will stay in the oil. So this is a way of separating using the extraction. Some will end up in the oil, some will end up in the water, and we separate the oil and water because, take a look, they separate themselves. So it's easy to separate whatever's in the oil from whatever's in the water. This, by the way, this kind of glass, this container, it's called a separatory funnel. So we use this technique to separate acids and bases and neutral. Now, how's it done? Here are the rules. Here's what happens. If you have, let's say in water, let's say you have an acid. Add a base to acid. You will neutralize it, but you will turn it into an ion. A base will turn an acid into an ion as part of the neutralization. An acid will turn a base into an ion as well as part of the neutralization. It'll neutralize it, but turn it into an ion. So again, if you have an acid, put it into a basic water solution. Acid will be ionic. If acid will be ionic, the acid will stay in the water. Remember, if it's ionic, it'll be in the water. If it's not ionic, it'll be in the oil or the organic part, the organic liquid. Okay. So again, remember that ions are in the water. Neutral or not ion is going to be in the organic layer. So another thing to remember is when a base neutralizes an acid, the acid turns into an ion, and therefore will be in the water. And an